Now let me discuss today another topic, that is flow-oriented modeling. Actually, this is old versions of people that are going to do working or using this flow-oriented modeling. Flow-oriented modeling can be simply called as data flow diagrams. Now, how the flow will be goes on between the input and output, how this process will be goes, that will be represented. So this flow-oriented modeling can be represented with the help of DFD, which stands for data flow diagrams. But data flow diagrams, rare applications are going to be using over there. It's a little bit of outdated one. So that's why just for a glance for you as part of the syllabus, I'm just covering that. Okay. So flow-oriented modeling, let me have look into that flow-oriented model. Right. So hope it is visible. Fine. So coming to this flow-oriented modeling. So flow-oriented modeling, the name itself represents how data objects are transferred as they move through the system. Data objects, just now we have seen any external entity, we can be considered as a data objects. Now how the data will be flow between the input and output, how this will be flows transfer throughout the a movement of that data throughout the system will be represented with the help of flow-oriented modeling. So flow-oriented modeling can be represented in a diagrammatic representation through the help of DFD, where DFD stands for data flow diagram. Okay. So if you consider, say for example, old school approach, flow-oriented modeling continues to provide a view of the system that is unique. It should be used to supplement other analysis model elements. Old school in the sense, like normally we can represent it how we need to reach from source to destination by representing some rectangle shapes, flowing of that, or by using the circles. After this, moving to this state, we have to move another state. Based on some constraint, we can move one after the other. In the same fashion, this flow oriented also. Flow in the sense how a process will be goes inside. Now, if you think about this, a flow model example, as I said, every computer-based system is an information transfer. Every computer-based system is between input and output. How this computer-based system will be works means how the process will works over there between the input and output. So already we have seen the example also in the previous topic, how this domain analysis will be goes on. And the notations to draw the flow oriented modeling we are going to using, these are the 4 different notations we are using. The first one, which is a rectangle, which is called as external entity. A circle here indicates a process. Wherever the process is there, between the flow oriented modeling, between the flow of your project, you can use the process symbol as circle. And we have a arrow mark, which is a data flow. And we have a 2 lines which look like as assignment, but it's a big assignment of this is a data store. So 2 arrow marks, arrow in the sense 2 lines will be considered as a data store. So here the 4 notations we are going to using. One is external entity, second one is the process, third one is the data flow, fourth thing is data store. And if you talk about the external entity, the first notation, for what purpose we are going to using this external entity is whenever you are producing something or when you are consuming something. Example, producing means giving the input to a program. So you are generating the input over there. That is called as producing. Consumer is nothing but the after giving the input, it's generating. The output is considered as a consumer. Another best example, one is producing, another is consuming. The manufacturer peoples are producing the products, and as you as a consumer, you are purchasing that one. So producer, consumer, all such type of things we can be represented as external entity. Example, a person, a device, a sensor. So already many more examples already we have discussed in the last topic. Another example for computer based is data must always originate somewhere and must always be sent to something. Means it has started at one location, it has to ended at another location with doing something, with something over there. Means it's not like that. When it is started from the origin, the value is x equal to 10. At the destination, when it is reached to the another location, that is destination, again the x value is equal to 10 means it is not external entity. The meaning of here is when you are giving something as an input over there, it has to be do something. It has to be produced at somewhere and with something. It should be something there. At least x equal to 20 or x equal to 5. Some variations will be over there. Another example, if you give the input as 10, 11 for addition, it has to give the output as not 10 plus 11. It has to give the output as 21. That is way we can represent it, this external entity. There is a meaning here. Data must always originate somewhere and must always be sent something. Okay. And coming to the second notation of this DFD process, when we are making a data transformer means changes the input to output. When your transformer going to be making a data over there, you can represent circle. So example for this one is compute taxes or determine area, format the report, display graph. At these positions, you can use the symbol called as circle for process. So when you're computing statements out there for calculating the tax, or when you're determining the area of a circle or area of a any cylinder, or we are making some formats for a reports at the time or displaying some graphs, at these positions, at this data transformer, you can use the notations process as circle. So data must always be processed in some way to achieve system function. So that is another quotation for process. The third notation for data flow diagram is data flow. So data flow through a system, this is arrow mark. Data flow through a system beginning as input and be transferred into output. So when you are giving the input here in the starting, like base, height, for making computing of calculating the triangle area for a triangle, now it can represent it this data flow symbols. So data flow symbols will represent it as arrow mark for the purpose of giving input for a process, because this is a circle means what? It is a process. For giving a input for a process and getting the output from the process, we can represent it data flow, that is arrow marks. And the last notation in the data flow diagram is data stores. So data stores where we can store some sort of data which is coming from, say for example, you are getting this some input from the sensors. Best example, when you are taking your mobile, you are giving the input as a voice, for example, that has to store. Then only it can be compute whether what you have to speech over there. Another example, you touch something on your screen. What you have touched, for which app you have touched, that it is sensing the app, sensing the screen. Then after storing that touch values, then only it will be act according to that one. Whether you have opened the phone pay, whether you have opened the any other game app, whether you have opened any Zoom app, what sort of things you have done it. So it will be sensing first of all through touch or through voice or through making some any entering some inputs, like we can give different inputs. So whatever the inputs you are getting from maybe some sensors, different types of sensors, or report, or from the text, or any other sort of input, lookup sensor data will be stored here, and based on that it will be act the based on the type, based on the sensor number, based on the location, based on the age, it will be react for particular input. So after getting this type, location, age, sensor number, here it will be stored. Based on that it will be react for your input. Okay, it's not like simply once you touch to the screen automatically you not get the output. So it has to sense that what type of input you are expected, you have given through the sense, through the touch, or through the voice, through the text you have given. That has to store at particular location. To store such type of things, two rows here we are going to using two lines to store the sensor data, not only sensor data, for data storage. Okay, so if you look off this, we need to follow some sort of like what we say, the diagrammatical guidelines. Like all icons must be labeled with meaningful names. All icons in the sense, whatever the icon you are using, it should be labeled. Labeled in the sense we have to give the name for that arrow mark, or name for the process, name for the external entity. Without that label, it is invalid the DFD diagram. So the DFD evolves through a number of levels of detail. Number of levels in the sense, like level by level, if you're moving like level 0, it gives some normal information, abstract level information. Level 1, it gives some detailed information. Level 2, again more detailed information. Like this, they are going to be providing different levels of DFD diagrams. So level 0 indicates abstract details, only just a glance details, which are main details which you require. Level 1, little bit of more details compared with level 0. Level 2, little bit of more details compared with level 0 and level 1. So as the number of levels is increasing, the details of a particular project or a particular product will be goes on detailed way. So if you want detailed description of your project, you can go highest level, that is level 2, like this. If you want a little bit of abstract level, level 0. If you want normal as a glance of details, you can go for level 1. So always begin with the context level diagram. Context in the sense, based on the situation where for what purpose you are going to drawing for that, that context level diagrams also called as level 0 diagram. So always show external entities at level 0 and level 1. And level 0 data flow diagram should be depicted with the software or system as a single bubble we can use here. So primary input and output should be carefully notated. So refinement should be begin by isolating candidate process, data objects and data stores to be represented at the next level. Meaning here is refinement should be begin at isolating candidate process. Later we will focus on data objects, later we focus on data stores. So all the arrows and bubbles should be labeled with meaningful names. So information flow continuity must be maintained from level to level. So one bubble at a time should be refined. So we'll see some examples what this all guidelines, whatever we have just now discussed with this. Let me see the examples for these guidelines. So let me construct a DFD diagram for level 0. To construct that one, level 0, review the data model to isolate data objects and use a grammatical first to determine operations. Now determine external entities like producer and consumers of data, create a level 0 DFD. Now how the level 0 will consisting, what type of details we can give here is, only we just review the data model to isolate data objects and use a grammatical parts to determine operation. That's only we just represent what are the data model look like, how many data objects are there, and how many external entities are there, and how it look like, and what are the operations between that. That's all. Not more details about this. The example here, when you see here, this is called as an external entity. Agree? So control panel, sensors, control panel display, alarm, telephone line. So the input for this process, this is a process. Safe home software is a process. So the arrow mark over here, it gives as what? It's a data flow. Now here there is no data store. So the inputs here is two external entities. One is control panel, another is sensors. The output for this process is, for safety home software, is control panel display, alarm, telephone line. So how we are giving input for this? Through the data flow. So this is not arrow mark, this is a symbol called as data flow. So we are labeling here as user commands and data. And here we are labeling as sensors status. Now for this external entity, we are giving the label as control panel. For this external entity, we are giving the label as sensor. Now this is a process we are labeling as safe home software. And the output here, data flow output from here is display information is the label for this one. Alarm type is the label for this data flow. Telephone number tones is the label for this data flow. And for this external entity, output external entity, this is consumer. This is we can call as producer. This is we can call as consumer. So control panel display, this is external entity producing, alarm labeling over here, and telephone line. This is another external entity producing external entity, means output external entity. So this is one DFD diagram. So in this level 0, we are just giving what's the inputs we are giving and what's the outputs we are going to be expecting over there. Okay, and this is a detailed description how it will be goes on. If you're coming to the next part of this, that is level 1. So if you come to the level 1, constructing, how we are going to constructing means, here grammatical force on the narrative that describes the context level bubble. Here bubble in the sense like some more details we have given over there. So isolated all nouns and nouns phrases and verbs and verb phrases. Verbs are here called as processes, which are represented as bubbles in a subsequent DFD. Nouns are external entities, data objects, control objects, data stores. Now what we are going to be representing here is, for verbs we are mentioning as processes, for nouns we are mentioning as external entities or data objects or control objects, or we can call as data store. So verbs can be represented as circle because it's a process, and nouns can be represented as rectangles, or we can have a two arrow marks, two lines, or we can making as or we can use for data objects also a rectangle symbols. Now, if you see a small diagram, it has a DFD level 1. So here, as I said you, we are considering all the verb phrases, that is, which represented bubbles in the sense here, bubble called as circle. For circle, they are called as bubble. I am saying as a circle for process, they represented the name as bubble. So don't be confused. Bubble means it's a circle. Okay. So here the verb faces all bubble. This is the bubbles circles representing all the processes. Now here the other nouns like control panel, sensors, control panel display, alarm, telephone. If you compare for this figure, it look like as a abstract level, not having more details. If you see this figure, level 1, the previous figure is a level 0. This is level 1. If you see this one, comparatively, when you compare that and this, it will be a detailed information, more information you are providing over here. So how the user commands and data is giving, interact with user, enter the password, process the password. If it is valid, display the message and status. Once it is, make sure whether active or not. When we require any configuration, we apply for the configuration system. It will be monitor whether the given input is correct or not. All sort of things we are going to be representing. But what you need to be observed, compare with this, we need to observe is, what you had to people observe is detailed information. When you are giving detailed information, the level is increasing. So previous level 0, it gives abstract details. Now level 1, it gives more details. That's what where you can observe here. So here also we are using configuration information to store. So this is called as data store. Configuration information representing with the help of the notation data stores, right? So level to level, when you are observing here, level to level, it is going to be talking about, it is detailed information. When you are going to be talking about, compared to this figure, more information you are providing. That's only one difference between level 0 to level 1. If you want more detail, you can go for another level 2. And how we are going to be making construction of this level 2 is defining the monitor sensor process. Meaning here is, if you are make another details, like here configuration information, if you want add more to the level 2, what we can do is, here I am just expanding the configuration information data store, expanding such a way that in level 2 I am defining the monitoring sensor process. How I am defining the monitoring sensor here is, for configuration information, still it is expanding, like read the sensor, how you can assess against the setup whether the sensor is triggering correctly or not to the microcontrol. What is the format of data it is want to display in the sensor, like sensor id, type, location. It will be generate any alarm signals whenever any out of bound the input have given, telephone number, like when you have dialing the telephone number over there, how to assess all such type of detailed information. What we are trying to here is, for the DFD level 1 diagram, here for the configuration manage information, I'm just expanding little board and giving more details in level 2. So if you combine these two diagrams, it look like as a big diagram which gives you a detailed information, what actually each notations will do, what a process will do here, what's the external entity will do here, what's the data flow has to do here, what's the data storage has going to doing over here, how the entire safety home application is detailedly processed over this. So like this, we have seen three different diagrams which talks about, when you want a abstract details, it's a level 0. When you want little bit of more details, level 1. When you want more details, it goes to level 2 as well. So, okay. So that's how we can be go one after the other. So this is a description for PSP PEC here for safety home security function. This is a normal description. You please walk through that also. So what we have learned in this here is, we have learned what is the purpose of flow-oriented modeling, how we are representing is with the help of data flow diagram, and now what are the notations we are going to be representing. What are the notations we are have to use is, these are the 4 notations: external entity, process, data flow, data store. So as a detail, if I let me see little bit of some more detail information. If you want more like data flow diagrams for flow oriented, is where we are using is in the framework activity, system analysis and design. Where do we can fit this is, we have a life cycle of phases like communication, planning, modeling and construction deployment. So in this one, we are adding here in the part of analysis. So analysis, what do we do for this is to find the fact finding, investigate business process and the current system. We are going to using this flow oriented modeling the current and required system, like how what the deliverables we are giving. Deliverables means outcome, means output, requirement specification, logical models of the required system. We are giving output for this. So to represent that, we are using DFD diagrams. So DFD describes the flow of the data or information into and out of a system. So what does the system do to the data means a data DFD is a graphical representation of the flow of data or information through a system. So we have, just now I said, it is consisting of 4 different elements like external entity, process, data store, and data flow. So what external entity will do, like for people, organization, we can use as external entity as a rectangle. Now process, it will be what happens to the data. So the process has transforms, we are going to using over there. Data store for permanent data, data flow, the flow actually between the input and process, we are going to use it. So these are the notations already we have seen just now, how we are going to representing over. So DFD shapes for version 5.0, which is look like as this, and in 2000 the versions, this is the symbols notations they are giving. Okay, so in this slide what we are observing is how we are representing is like eclipse for the process. How we are representing for the process is in later versions is like this, and data store is like this, later version like this, and external entity is like this. Again it is representing as cube shape. Okay, and levels of DFD, just now we have seen use level DFDs view system at different levels of detail, and overview of many progressive greater detail views are there. Level 0 talks about the model system as one process box which represent the scope of the system. So just identify the external entities and related inputs and outputs, and like here an external entity will be there, input and output data flow will be there, and a just we have a process, right? Just normal information. For level 1 it gives overview of the full system, like identify major processes what you are doing inside the project and data flows between them. Identify data stores that are used by the major process. Boundary of level 1 is the context diagram. So context diagram also called as DFD level 1 diagram. So level 2 gives talks about the detail, like process is expanded into more detail. Each process in level 1 is decomposed to show its constitute process. Boundary of level 2 is the level 1 process. So expanding of level 1. Previously if you observe, for context information, for configuration information, what I'm done in the level 1, I'm expanding, means the boundary of level 1 is depends on the level of level 1 process. So from level 1 process only, I'm expanding that configuration information for giving more details. That's what we have done it, right? So hope you remember. So other notations, like we can, for duplicate marked by diagonal line, we can use for any duplicates marks. System boundaries we can represent. Elementary process we can represent with the help of star in corner. Process that we level, we can use the dots at top. Okay. So rules already we have seen. Rules for DFDs: numbering, we have to give must and should numbering. Labeling, balancing. Now let me see. Numbering means for level 1 it is 1, 2, 3. If it is a level 2, x.1, x.2, x.3, like this, where x is the number of the parent level 1 process. So the number is used to unique identify process, not to represent any order or processing. Now data stores number usually D1, D2, D3. Like this we are labeling over there. And labeling for the process labels is just a short description. Just now we have seen in the example, like for the process, we are making a circle, like safety home, like this we are labeling. For data flow label, noun representing the data flowing through it. That is example, customer payment, tax or income tax, like this. Data storage labels can describe the type of data store. Make labels as meaningful as possible. So whatever the labels you are giving for, maybe for external entity or for a process or for a data flow or for data store, labeling should be gives a meaningful, suitable names for them. And balancing on data storage, balancing is any data flows entering or leaving a parent level must by equivalent to those on the child level. So data stores that are local to a process need to be included until the process is expanded. Okay, so this data flows already we have just now discussed with an examples. Now context diagram is also called as level 1. Let me see one small examples how the context diagram will look like. So this is the, we are using in the analysis part. Like here in this customer admin Unicom's website, you are registering for this PayPal. So these are the external entities in the rectangle. So these are the process. So how many processes are there in this figure? One process. The name is Unicom's website. The external entities are customer, admin, PayPal. Now how this process and external entity connecting with the help of data flow. With the help of data flow, it is going to be connecting over there. So each one, the external entity is labeled with customer, admin, PayPal, and the process is labeled with Unicom's website, and the data flow it is going to be representing with the labeling as register, login, customer profile, product order. Like this, it is labeling. So it's a meaningful labels we are going to do it over there. So this is normally total contest diagram. If you talk in the level 0, if you talk the same in the level 0, admin, buyer, and the Unicom online website, two external entities are there, three external entities are there, one process is there. Just we are giving a detail. Admin can product, there is user category details. Means in this website, they can be put the products over there. They can allow the users, they can allow the users to categorize the total details. And whatever the orders are getting, it will be sent to the admin. So detail information, not that much detail, only abstract levels we are giving. What type of responsibilities this website can do with admin, admin can do what for the website, buyer can do for what with website, website can do what for the buyer. If you have seen the level 1 diagram, this is a level 1 diagram, previous level 0, level 1 in detail. Like we are increasing the verbs phrases as well as noun phrases, whereas verb phrases called as the represented with the help of process, whereas noun phrases we can represent with the help of the external entities or data objects or data stores we can represent, right? So here the external entities are there and the processes are there over here. Okay. And if you want the detail information, the same we can represent like this as well. Okay. So the same example for a detail of this. So I'm just expanding for the previous figure, like how in the level 2, like in the previous example, how we are expanding the configuration information. This also we can expand. So giving more details, more and details is called as the, we can represent with the help of data flow diagrams. Okay. So whatever we have discussed for this, that's about the flow oriented modeling.